Alrighty, welcome everyone. So in this problem, or in this video, we're going to be looking at finding the area between two curves. So let's begin with example number one. It says find the area bounded by two functions. You have y equals 3 minus x and y equals x squared minus 9. So ultimately, we are going to be applying the area formula for between two curves. And that area formula is given as A equals the integral from A to B of f of x minus g of x dx, where you could think of f of x is your top function and g of x is the bottom function. All right, informally, what we're looking at here is if I draw two curves, let's say here in purple, I draw the curve of f. And let's say I drew a curve in a lighter shade, like more like pink for G. And let's say that it's bounded between A to B. Oops, sorry, there's my B. What we're doing is we're trying to find this area, the area of this region. So essentially, to find that area, we use an integral. The integral is a definite one. It's from A to B of the top function f minus the bottom function, which we labeled as g. Okay, so for this particular problem, what you're going to need to do is first find the points of intersection, right? Ultimately, when you're finding the points of intersection here, it gives us the values of A and B, right? So step one, find points of intersection. Give me 1 second. I'm just pulling that door. It's really loud. Sorry about that. It's like really loud out there. I just couldn't concentrate. All right. So to find the points of intersection here, you set the two equations equal to each other, and then you're going to solve for x, right? So we'll have x squared minus 9 is equal to x minus, 3 minus x. So the way that this works is that everything that's on that right-hand side of the equation, I'm going to move it to the left-hand side of the equation. So I'll subtract 3 and add x on both sides, right? So I'm adding x, subtracting 3. Okay, so what we're going to get is x squared plus x. Negative 3 minus 3 is minus 12 is equal to 0. Okay, so we have a quadratic function there, or a quadratic equation, x squared plus x minus 12. What you need to do is ultimately find two factors that when you multiply them, that gives you negative 12, that adds up to positive 1. So what are two values that will, when we multiply them, give us negative 12 that adds up to 1? 4 and negative 3. That's right. So we're going to have x plus 4 and x minus 3. So when I split this into two equations now, x plus 4 equals 0, and x minus 3 equals 0, we're going to get x equals negative 4 and x equals 3. So those are your points of intersection. Ultimately, the x equals negative 4, since that's the smallest of the two zeros, that will be my A. X equals 3 is my B. All right, pretty good. Now we proceed to step number 2. Step number 2 is where you make a sketch of the function. So sometimes your professor will, when they give you this particular problem, right, where you had to just find the area bounded by two curves, they would ask you to make a sketch. And they would give you some partial credit or give you some credit for making the sketch. So that's our step 2. Step 2 is to make your sketch. The good thing is that the equations that we were given were y equals 3 minus x, and we were given y equals x squared minus 9. So these are elementary functions that we can ultimately draw, right? For example, what would the graph of 3 minus x look like? It's a linear, so it's going to look like a line. And y equals x squared minus 9. I like a parabola. Very good. So here goes. Here's my sketch. Here's the y-axis. Here's the x-axis. So we have that. Here's our origin. We're graphing this from -4 to +3. Just note that this is not drawn to scale as well. Okay, so that was funny. All right, so let's see what happens. In the first equation, where you have y equals 3 minus x, for y equals 3 minus x, just writing out here, when x is equal to 4, what is our y value? Y will be -1. And if, sorry, this should have been -4, sorry. When x is equal to -4, our y value is positive or negative? +7. That's right. So this will be 3 minus -4, which is the same thing as 3 plus 4, which is 7. Good. Now, when x is equal to 3, you're going to get that y is equal to 3 minus 3, which is 0. So two order pairs that I automatically have are -4, 7. 3, 4, 5, 6, 7. So that will be 1 point. The second point will be 3, 0. And then you can connect that with a straight line. All right. Now we can graph y equals x squared minus 9. First of all, for y equals x squared minus 9, when x is equal to -4, we're going to get that y should be -4 squared minus 9, which is 7, right? -4 squared is 16, so 16 minus 9 is 7. Now, when x is equal to 3, you're going to get y equals, sorry about this, 3 squared minus 9, which is still going to be 0. So both of these order pairs are the same, which makes sense, by the way, because both the line and parabola should intersect at the points -4, 7 and 3, 0. All right. Now, to make your graph of x squared minus 9, it should look like a parabola where the vertex is at the order pair 0, -9. So on my y-axis, I got to go 9 units down real quick. 3, 4, 5, 6, 7, 8, 9. So here's my vertex. And we could draw a parabola. So the parabola will look something like this. All right. So we have our line. The line was being drawn. And now we have the parabola. But more importantly, in the region of -4 to +3, you can identify now your top and bottom functions. Right? What is my top function? Y equals 3 minus x or y equals x squared minus 9? Yeah, this is going to be the top. And y equals x squared minus 9 is the bottom. The reason why I label these as my top and bottom now is now step 3 is where you set up the integral and compute the area. All right, so step 3, set up integral, then compute. All right, so I'm just going to slide this down. So we're going to have area A is equal to the integral from -4 to +3 of 3 minus x minus x squared minus 9 dx. So one thing that I recommend to do is when you set up your integrals, especially for the area problem here, have your f of x, the top function, be put inside of parentheses and put the x squared minus 9, the bottom function, also inside of parentheses. The reason why is because they're both separated by a minus sign. And if you do not make this or do not insert these parentheses, you can make a mistake with the signs. Okay. So let's actually compute this area. So what we're going to get is from -4 to 3 of 3 minus x squared minus 9. So here I can distribute the negative sign. So the x squared term is actually a negative, but that if I distribute the negative sign to the -9, it becomes positive. And we can combine the +9 with the 3. What is 3 plus 9? 12. So we're going to get 12 negative x, right? Because there's nothing to combine the negative x with. And then followed by negative x squared dx. All right. Our next step now is to take the, so once we have it set up, we can now do the computation. So the computation says that we have to find the antiderivatives for 12 minus x squared. So what is the antiderivative of 12? 12x. Antiderivative of negative x? Negative x squared over 2. The antiderivative of negative x squared? Negative x cubed over 3. And again, this is now going to go from x equals -4 to x equals 3. So by the fundamental theorem of calculus, you know that you have to plug in the upper limit of integration first. Then you plug in the lower limit of integration. Now, the good thing is when you take your antiderivative, by the way, and especially when you're going to deal with applying fundamental theorem of calculus, have the antiderivative inside the brackets. It's helpful. The brackets are helpful because you'll see that eventually when I compute this, we're not going to make a mistake, or hopefully when you're going to do it on your own, you won't make mistakes with your signs. Okay, so we're going to have 12 times 3 minus 3 squared over 2 minus 3 cubed over 3 minus 12 times -4 minus 3, or sorry, -4 squared over 2 minus -4 cubed over 3. All right, what is, let's actually work this out. What is 12 times 3? 36. So we're going to get 36. 3 squared is 9. So you can get -9 over 2. 3 cubed is what? 27. But we're dividing it by 3. So that could be simplified. What's 27 divided by 3? 9. So you get -9. Okay, I'll come back to here. Let's just work on the second set of brackets. What's 12 times -4? -48. Then -4 squared. +16, but 16 can be divided by 2. So 8, that's going to be -8. And then -4 cubed is what? 64. So you get -64 over 3. That can't be simplified. But since this piece is -64, when I have two negatives next to each other, they become a positive. So it's actually a positive 64 over 3. All right. So what I'm going to do now in my second line, I'm not combining anything yet. But what I'm going to do is the minus sign now that's separating the two brackets, I'm now going to distribute it inside the second bracket. Okay. So we're going to distribute it here, there, and there. All right, so we have 36 minus 9. Okay, we can actually work that out. 36 minus 9 is what? 27, there you go. So we have 27 minus 9/2 plus negative of -48 becomes 48. Negative of -8 becomes +8. And then the 64 over 3 becomes a negative again. All right. So what's 48 plus 8? 56. So this value here is going to be 56. So what happens when I take 56 plus 27? 83. Okay, so we're going to get 83 minus 9/2 minus 64 over 3. Now you can write 83 as a fraction by saying 83 over 1, and you can find the LCD of these three denominators, 1, 2, and 3. What is the LCD of 1, 2, and 3? 6. There you go. So note LCD of 1, 2, 3 is 6. So I can change all of these fractions to have a denominator of 6. Okay, so if I change 83 over 1, namely that 1 become a 6, then I had to do 1 times 6, which is 6. Now, what's 83 times 6? Well, here's my tip. Do 80 times 3. That's something, 80 times 6. That's something that you guys can do. What's 80 times 6? 480. There you go. You said it. 480. And what's 6 times 3? 18. Now put it together. What's 480 plus 18? 498. You got it. 498. Very good. All right. The other two, I don't think it will be that bad. We have that the 2 is being changed to a 6. So we had to multiply by 3. So we had to multiply 3 on the top. 9 times 3 is 27. Now you have 64 over 3. The denominators is going from 3 to 6. So you had to multiply by 2. So you multiply 2 on the numerator. What's 64 times 2? 128. All right. And now you can subtract the numerators and then leave the denominator alone. So what's 498 minus 20? Well, we could do 498 minus 128. That's easier. 498 minus 128 would be, I believe, 370. So you're going to get 370 minus 27. And what's 370 minus 27? 343. So you get 343 over 6. I don't think this could be simplified any further. I don't want to simplify it any further, and this will be your final answer. So the area underneath the two curves, which were y equals 3 minus x and y equals x squared minus 9, is 343 over 6.